Hello everyone, this is Mr. Naj, and today I'm going to be talking about slopes and areas. So we finished the constant velocity particle model lab, and then after that we did the uniformly accelerated particle model labs, two of them, SELF 05 and SELF 06. So what I'd like for us to do right now is to summarize a little bit what we found, but referring to the graphs. So in this case, if we have, let's say, a constant velocity particle model, let's say this is the time measured in seconds, this is the position measured in meters. What we found out is that the position versus time would give us some kind of a straight line with a slope like this. That's in the context of constant velocity particle model. Then we decided, okay, so what would the slope represent? Well, to determine that, what we did is we took the vertical, change over the horizontal change. Well, the vertical change is the delta x, the horizontal change is the delta t. Therefore, we end up with the slope, okay? The slope being equal to delta x over delta t. And then when we looked at the units of that, it seemed to match with the unit of displacement, which is meters, the unit of change in time, which is seconds. So that gives us meters per second, and then we reasoned that has something to do with velocity. So this would be the velocity sub x. So from this, we concluded then that the slope of the position versus time graph is representing the velocity. Now, since the slope is constant in this case, that means if I go ahead and try to graph now the time in the x-axis and the velocity in meters per second in the y-axis, we should be able to get, based on this is a positive slope line. Therefore, we should be able to get, remember the idea of using the green to represent velocities, the blue to represent positions, and the red to represent the acceleration. So that means we would have some kind of a straight horizontal line like this, indicating that the velocity is not changing because of the fact that the slope here is not changing. Now, if we take the slope of this, that would be, the slope at that point will be equal to the change in the velocity along the x over the change in time. And from that, we would get a new concept, and we refer to that as being the acceleration. Since this line is horizontal, in this special case, the slope is 0, therefore there is no acceleration. Well, that makes sense because we're dealing with a constant velocity particle model in the first place. Cool? Okay, now, at this point, if we decide that we are going to graph the acceleration versus time graph for this specific motion, meaning the constant velocity particle model motion, then we're going to end up with the time in seconds, okay? And the acceleration in meters per, come on, square second. I hope you said that, okay? And then at this point, the acceleration, if we go back, we see that the slope of this green line is 0. Therefore, in this case, we're going to end up with a horizontal line right at the 0, representing the acceleration is equal to 0 meters per square second. Why? Because we are still dealing with a constant velocity particle model. Cool or no cool?